as we're not in the field, we're now going to read a file back from disk that we recorded earlier, so we can see what a typical field looks like and how we can manipulate it in the field to quality control the data and make sure that the data we're recording is of good enough quality to interpret later on. I will make it clear at this point that the software that comes with the geode, which is called Size Module Controller, is field acquisition software. It is not data processing software, which we'll cover in a separate tutorial using Size Imager software. So at the moment we have our three windows. We have our shot window, our noise monitor and our log file. Now from now on we're going to be purely looking at the shot window. The other two windows are irrelevant, so I'll maximize the shot window and I'll come here to File, Read Disk, and I shall read back a file that we recorded earlier in the field. Click on Open, and now we see a typical refraction data set. Down at the bottom here on the geometry, it shows the geophone positions. It shows that we had a geophone missing at location number 7 because we had an obstruction along the line, so we couldn't place a geophone at this position. And then offset from geophone number 24 is our hammer position, way over here on the right of the screen. If we examine the data on the screen, we can see very clearly that channel number 17 is very noisy and there's no real signal on it. Most probably this was caused by a fault in the cable, but we still have 20, in this case 22 active geophones, so we have enough data to work with. We'll come here to display. Anything that we do within the display window will only affect the cosmetics of the screen. It doesn't affect the raw data which is being recorded onto disk. So for example, if I come across here to display boundary, if I wish to expand or contract the viewed record, I can come here to my end time, and if I put in 0.5 of a second, we'll see now that the data is compressed. If I wish to expand it again, I'll put in 0.2. And we'll expand it out because really for refraction we're only interested in this top portion of the screen up here from our T0, which is our trigger point, down to where our first arrivals are, which in this case is at this location here. If I wish to examine, for example, the first 12 channels in more detail, I can put in number 12 as my end channel, click on Apply, so now I'm only displaying the first 12 channels, and so on. We'll put this back to the original acquisition parameters. Click on OK. Back into display. Now at the moment we're displaying the data in a fixed gain style, which is the most applicable method of gain display for refraction data, and it means that the gain which is applied to the signal is the same across the whole recorded length of our data file. Our trace style is variable. We have 3 different options with the geode. I can turn off the shading totally if I wish, or I can have a halfway house in between the variable area and the wiggle trace, which is called shaded, and also, which we can apply to any 3 of the trace styles, I can clip the waveforms, which is quite a useful feature if we're trying to pick our first arrivals and we've got large amplitudes on adjacent traces which may be overwriting our first arrivals. If I click on Apply, you can instantly see now that all of our waves have got their apparent peaks and troughs chopped off, and they're not overwriting the adjacent channels. If I don't like this effect, I can simply turn it off and go back to how it was before. So using this window you can choose which is the display method which you prefer best. We'll use variable area in this case. Now we may want to adjust the trace sizes. We can do this by letting the computer do it for us, by coming over to Do Survey and clicking number 6, Auto Scale Traces. At the moment this hasn't done apparently anything because the computer is quite happy with the trace amplitudes which it sees within this recorded time window. But whilst the trace amplitudes may be perfectly acceptable over here on the right for the upper channel numbers, once we come down here to channels 1 through 5 or 6, then the trace amplitude is probably greater than what would be reasonable. So if I come here to File, to Display, Shot Parameters, Display Gains, and I'm now going to select Individual, click on OK, and at the bottom right of the screen I get a cross, and I can use the up and down, left and right arrows to adjust the amplitude on any particular channel. The channel which is active, which I'm working on, is highlighted in green. So now I'm using the down arrow key and we can see the trace amplitude being reduced. Move across to channel number 2 and so on. You need to adjust the trace amplitudes so that you can still see the first arrivals quite sharply, but you're not distorting the data. When I'm happy that I've got my trace amplitudes adjusted correctly, I click on Escape to come out of the edit mode. It's important with seismic refraction that you do examine the data closely in the field, because it's absolutely critical that you're able to identify where these first arrival points are, or first breaks if you like, because quite often what looks like good data when you're in the field, when you come back to the office to try and edit the data and process it to interpret it, these first arrivals may not seem very sharp, but by then it's too late. At the moment, if I wish to increase the amplitude of these and therefore process the data with a greater accuracy, I can stack more times with the sledgehammer, which will increase my signal to noise ratio and make these first arrivals sharper. The final thing which we'll just talk about right now is within the shot parameters are display filters. At the moment these are off, and similarly to the acquisition filters, I can apply some filters to the recorded data. However, unlike the acquisition filters, these filters we can change. So if we don't like the effect, I can simply turn them off and go back. So for example, if I apply a low cut filter of 30 Hz, click on Apply, you can see that our data has now been cleaned up a little bit. If I go right the way up and let's put this in at 100 Hz, a large amount of the amplitude of our data has gone, which means most of our data has got a dominant frequency lower than 100 Hz. So in this case this is probably not a very good filter to use. So I'll turn it back down again and apply a filter of 20 Hz and we get our data back. Or I can turn it off totally